Good day. In this video, I will show you how to rate the circuit breakers. In rating the circuit breaker in ETAP, we are considering the kilovolt rating and the continuous duty of the breaker that we manually compute. The results of the manual computation can be seen in the screen. So, for example, in high voltage circuit breakers, we are to put the rating of the breaker 1 or the power grid breaker. So, we can see that the details of breaker 1 has 1520.90 ampere for full load current, a kilovolt rating of 13.8 kilovolts, and a continuous duty of 2000 ampere. So back to the network in ETAP. So we should double click B1 and go to the rating tab. Select the library button, and now we can see that the library quick pick window will pop up. So considering that we have a continuous duty of 2000, we should know that the continuous ampere in ETAP and the continuous duty that we manually solve is equal. But aside from the continuous ampere, we should also consider the maximum kilovolts, which is equal to the size up of the kilovolt rating that we solve manually. So the kilovolt rating that we have manually is the 13.8. But because we don't have any 13.8, if we scroll down here, we don't have 13.8 rating for the max kilovolts. We should size up the maximum kV and pick the value that is closest to 13.8, which is in this case the 15 kilovolts. So now to pick the suited breaker, we should look for 2000 for continuous ampere and a maximum kilovolts of 15. So we can see that this breaker here has a continuous ampere of 2000 and a maximum kilovolts of 15, which is exactly what we needed. So click OK. And now we can see the details of the breaker that we selected. It has a 15 maximum kilovolts, a continuous ampere of 2000, a rated interrupting capability of 63, a max interrupting capability of also 63, the CNL and RMS and CNL peak that we will need later in the short circuit analysis. So click OK to save the details. So one thing also to remember that the value of interrupting duty is from the rated interrupting kiloampere because this data will be needed, as I already said, in short circuit analysis. So now you have the rating for high voltage circuit breaker B1. All we have to do is repeat the process for all the other high voltage circuit breakers. For example, this B2, the rating that we needed is 13.8 kilovolts for kilovolts rating and a continuous duty of 3000. We have VHK 1000 as a model under ABB manufacturer, which has a continuous ampere of 3000 and a max kilovolts of 15, which is close to 13.8 that we are need. So click OK again to save the data. Then just continue to put the data based on this manual computed values. Oh, just a quick reminder that because we needed a 6000 continuous duty, and the breaker that we selected only have a 3000, it is because I can't see anything that has a 6,000 6,000 ampere as its continuous amp in the ETAP library. So I just chose what is close to the max kilovolts, which is 4.18. So I chose 4.76, and I will just manually type 6,000 for the continuous ampere. This is only done if we really don't have the exact value that we needed in the library. So click OK to save. I forgot to put it here, so I'll put 6,002 here. 8,000 and 4.60. Now for the low voltage circuit breaker, double click and go to the rating tab again. Then go to the library, and with this we should pick the type of power circuit breaker. Make sure that you click the power circuit breaker here, because the values of the molded case type is different from the power circuit breaker that we will use. So the computed value for the B11 or the breaker 11, which is a low voltage circuit breaker, is 0.8 kilovolts for kV rating and a continuous duty of 6,000. What we will do is look for a maximum kilovolts of 0.48. So we can see that we have 0.48 for the kilovolts here, but we also have to look for the fitted continuous duty, which is 6,000. So let's look for it. As we can see under the ABB manufacturer, that the only kV is 0.6 and 0.6335. Look for 6,000. But upon searching, we don't see any 6,000 ampere for the continuous, for the size of the breaker itself. So we will just choose the highest one, then click OK. Then manually type the needed continuous amp based on what we manually computed. Then click OK. Then after this, just repeat the process for all the other low voltage circuit breakers. Now we have the complete rating of our circuit breaker. We can now proceed to the power flow and the short circuit analysis.